Okay, well, the so-called short part 3 turned out to be almost 2 hours. No, that's of course including mistakes, the many mistakes that one makes along the way, even though I'd already done it before. Doing it again while making different mistakes. But instead of cutting out all of the mistakes, I figured I might as well just leave them leave the mistakes in, so you can see that doing this sort of thing is not it's not like what you read in a textbook. It's everything that one does involves trying something and getting something wrong and misreading something, a typo, and and that's just the way that things go. It's never perfect the first time, but eventually, though, you do get to the end. So, but what I will do is I'll try and find a good spot, an intermission spot, to cut this in half, around nearly half. So it'll just be 2 parts, and you can watch one part today and watch the other part tomorrow, and you'll know where to pick up from. Okay. Now, sorry, I might as well just start out here. I've been doing some music things. Alright, now it turns out I changed our program. I realized that SI would have been wrong for these comparisons too, and for the increments. It gets messed up by this in 21. So what I did is just the standard way of saving a register, push it, call the thing that messes it up, and then pop it back. Now popping, the pop instruction has no effect on the flag, unless you're popping the flag, of course. Yeah, I believe that's actually true. Let's see. I have this online, and that's why I'm trying to find it here. Here. This lists all the Intel instructions, and we're interested in pop word. Okay. Flags modified none. Okay. So this pop instruction here is not going to. Well, actually, the comparison is made after the pop, so that doesn't even matter. But if we were comparing a flag, possible flag alteration due to this call, then the pop wouldn't affect that either. Now, this is our string, and this is the end of our program is here. Right? Now, I was looking at this. Whatever. It's 1, 3, 8, 9A. That's the entire program. There's a lot of space we could probably, We need to move this string up. We don't need these no-offs here. So we did move this 120. The print went well. It's good to have a little space though. I got rid of the extra line here, but I'd like to bring this up to, let's say, how about 129, 12A. We move from 130 to 13. A is the end, B is the end, really. Although it doesn't matter. To 12A. Let's go all the way to there. Okay, blah 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 blah. Now 12A is our string. And here's the 24 is going to be a dollar sign. Then there's a null terminator because we want to keep. And it looks like our program ends at 133. It goes from 100 to 133. So 33 hex bytes. A file $space and then that's the last character of the program, which is 30, 1, 2, 3, right? So the difference is 33. Debug. Oops. Yeah, what's wrong with that? Capital enter from 100 to 1,000 0. Now why is it saying that? Also an error. Why do this? Oh, still. Okay. So I fill everything out to 0. Next. Now, I changed the position to 12A. That's the position of our string. Now, how can I get this here? I haven't executed anything. There's only 33 bytes. Okay, well, it's just, I don't know how come. The way that the debugger loads. Yeah, it's left over from a move. Okay. Yeah. Yeah. That's a signature. That's a signature telltale sign of what they call a copy down. When all of this stuff started out uh, 4 bytes. This is 1, 2, 3. Yeah, 4 bytes um, more than 100, and somehow and it was moved down, or something happened, and things were moved down. Now, let's see. Now everything should be okay in terms of code. The code ends at that return. There's no more code. The rest following here is data. So this should be the entire program. Let's see if it looks correct. Well, first off, SI. It's not 130 anymore. It's 128. But aside from that, uh, 128 there. It's good that I typed in 128 incorrectly. 127 is the end of the program. But we can see that R41 is just the character A. So function 29, DOS function 29, destination, it's going to write the meaningless data at 500, we don't care. It's going to get the file name from 128. We save off SI, call the function restore SI, check this flag. If 0 go to 119, calls 122. It's not 122, it's 120. I'm writing them out as I fix them. 120. This doesn't, that FF didn't matter. So I could actually reduce this slightly if I wanted. Doesn't matter. SI has been restored, so it points back to where it began. DL goes there. Return int20 gets called, and we'll quit. We'll print an A, right? Now, let me do that again. Unassemble from, the whole thing's 33 bytes. Now that's inclusive, right? 24 is a dollar sign, and 0 is the last 0. Now this is usually an inclusive thing, but actually I've specified a 34 bytes here. Like if this was a 1, right? That would be 2 bytes. So really it is 132 is the correct number to put here. Alright. Now I want to do that again. But I don't want to do it manually. In this script file, we'll have to say 132. So this is a script file. I'm going to call this dump script. And actually, I don't need anything else. So if I type that into debug, with the name of our program, it's going to beautifully open this file up and accept this as keyboard input, which does this unassemble and then quits. Now that's going to cause there to be printout, and we should see this printed out on the screen. And there it is, see? Okay. I don't want it on the screen, I want it in, we'll call it ASM. Okay, so now we have basically an assembler type version of our file, of our program. Now do I have, I need a decent editor now. That's almost assembler. Right? If we get rid of this stuff, then I can get rid of that much more easily with a decent editor. There are these no-ops, but it's not important. It takes a while to load. And position 12A is the drive letter from where this search begins. If I modify this to a 43, it's going to start searching from C. It's coming along, I think. And that should be a clue as to what I'm going to do. This here, nextdrive.com, is a program. This here is just a text file. I want to open it up in here. It will. And, I just want to use the column editing feature in this. Get rid of that part. Okay. Now, this here, if you look back, okay, now this IncCX is really where our string is, and the debug program allows you to enter data bytes in the following form. Just as I have, as this is written here. Okay, that's more. Now that actually accounts for all of this. Now that is a command that the debug program accepts. Okay, if you're assembling. I'm at 100 right now. Okay, 1, 0, 2, 3, 4, 5. See, just put those values in. Now that's just that string. You know, a 5 and followed by a 0. Okay. So as far as the debug program is concerned, that's acceptable. That makes it easier to read. All the rest of this stuff is acceptable. And what I can do I want to get rid of these tabs. There's tabs in here for some reason. Come on, cursors. It's going through a complicated. Okay, figured out what's going on. Figured out maybe that I want to do something like that. Get rid of tabs. I don't like tabs. It can be very confusing. That's okay so far. Okay, tabs. These are tabs. These tabs? No. Okay, well that's good. Now, if I were in the debugger and I wanted to enter in all its code, I would type the letter A, and then I would type all this stuff in, right? And then at the end, I would have to press enter twice to get back to the initial prompt out of the assemble mode. I might name my program. Right? And I would like to put into CX the size of the program, which was 33. I believe it was. Yeah. Then I'd like to write that out, and then I'd like to quit. Alright, so now here we have this is not a PASM anymore, this is a script. And this will produce that program. I'm going to call this close that. Type. Okay. Now let's see if it works. Now it's already, the name's already provided inside. Okay. Now there is, no, let's delete that first. Do that again. So there's nothing called nextdrive.com. Now there is. And printed out the letter A. Okay. That's the one. Bring that back in here now. Okay. Now suppose we wanted to create this script on the fly. What we could do is, if we had a destination, suppose this was within a batch file, and we had a destination, a folder. So we'll give it a name. Attempt folder. It's going to be a name that we're going to use again. So let's call it our binaries folder, something like that. Okay. Now I'm recording macro. Quotations are important in case the folder has spaces in it. Repeat that. I hope. Trying to replay the macro. Play. Try that again. Cancel that. Doesn't matter. Why macros not working? Okay, we'll do it one step at a time. Let's see, it's completely, it doesn't do it. Main macros. Need to exit this program, restart it. Oh, it's gonna work. Okay. Oops. Yeah, actually, just put dot for the just an empty name. Okay. He's on one. Too much. Now, if this were a batch file, and there were such a thing called binaries folder, executing these lines would create a file with this name, with these contents, and this here being an empty line. So I'm gonna close this and make that a batch file. That too. Okay. Now we don't have such a folder. I'm gonna invent this folder. Now, what do I know always exists? I know that user profile or something is always an existing. Yeah, user profile. And binaries. Call this Okay, now that there's a path. So I'll just set it to that. Set local so nothing remains. Now I'm just going to run this batch file. Now remember, this is not going to, the result of this is not going to end up where we are. Oh, now at the end of this sequence, I would like to type, why don't I change to that directory first? We'll move over to binary folder. We'll type this script file into debug. Okay, and return to where we started from. Okay, and now we can call next drive, right? Whenever we like. Now, I would like this to be a variable. It's currently set to 41. But anyway, I'll deal with that in a minute. And then at the end of this, I'm going to call the program just to make sure it works. Alright, that's the name of it. So we should be able to call it. Cannot find the file. I typed something in here. Those are all blank. Binaries folder. Oh, equals. Try it again. That almost worked. Cannot find the path. Oh, because we didn't make that directly. It takes a while to next batch file. I think we can do it all in one go. Well, it's off user profile. So if it doesn't exist, we'll make it. And then it should work, maybe. Okay, now I printed out the letter A. Now that program here, C users 16 that just exists forever now, right? If we could change this letter, we could make it start searching at a different letter. So how about we let this batch file take a parameter, %1. Now I would like to make %1. Oh, okay. If I want to use letter, I don't want to convert from letter to hex. We could discard that part and do the line above. And in the debug, it's actually running. I'm going to be on the wrong line. That's the problem. Now let's skip a line. Well, we can break out of the assembly mode this way. And enter, we know where we are. We're at 12A, I think it was. Let's call that %1. And we need to put quotes around it. Right, that enters that would change a character sequence. in this case, including only one character into its code. Okay. I believe that is 12A. Yeah, 12A. See, I could have done that as the first step, but the thing is when we hit 12A, we don't want to overwrite it. So I'm breaking out of the assemble mode, I'm entering it in here, and then I want to assemble 12B. I suppose I could have done that, but I could. Okay, we can do this first step. Okay, we'll enter 12A, the first parameter passed in. Here, we're okay so far. And we don't even need these two now. I can leave it. And we can even do this at the beginning. Okay, that would start us assembling at 12B, where we entered in the rest of that string. And then we want to start assembling at 100. Right? You see how this works? But I need to get out, in order to get to make this happen, I gotta get out. I don't need two of these. I don't need any of these. Oh yes, no, I need one of those. I gotta find out what. No, I don't need that. Yeah, I need that just to get out. Now, in order to start assembling at 100, I gotta pop out of the assemble mode, and then say I want to start assembling at 100. Okay, Now this should all work with %1 as an argument. We consider this an error. So if there's no argument supplied, this would become true, and we won't do anything. However, if there is, I'm going to enter into 12A the argument supply. Now we can do checks, but this is a totally internal thing, so we know nobody's going to use this. And I'm going to enter a letter A, B, C, whatever. Now we're not assembling anything yet. Here, this is an assemble 12B, and then here's what I want to put there. And then I want to break out and say that enter a command that I want to start at 100. Enter in all these commands. Don't even need these no ops. And then I want to break out, give my thing a name, and give it a size, etc. So notice there's no conf file in here. So if I now say next drg, nothing happened, right? And I'm going to say B. Well, this seems as good a place as any for the intermission. So I don't have any music, unfortunately, to go with an intermission. I might, but I don't know how to get it to get into the screen. I mean, into the video. So until you feel up to watching the rest, we cast right in the middle of a mistake, of the many mistakes there were. I think you probably know what I did wrong in that last one.